summary way of putting all the information together that we'll see on a day like today. And what it ends up looking like is something like this. Okay? So at the end of the day, you should have something that looks more or less like that. And what you're going to be looking for, we mentioned it briefly at the last site, you're going to be looking for groups of rocks that are similar to each other. Okay? And there's only about 4 major groups that are similar to each other here today. Now, probably all 4 of them can be seen right here. So there's that transgressive lag kind of deposit we talked about. That's the coarse grain material that forms the cliff up there. That's the second facies that sits immediately underneath it. You can see is that dark coloured material with all those light little silty layers in it. Halfway up the cliff is another unit that it's very dark coloured, hasn't got the silty layers in it. Next one down is a repetition of the second one that we saw at Bill's head level, same material. So that's the same facies as up there. And then this stuff down here is a different one again. So looking really carefully, 1, 2, 3, 2, 1. They're facies. They're different things. Think about them like food facies. You know, if you went to the restaurant and you kind of went, all right, well, what kind of food is this? And you didn't know much about food. And so you got a meal and it had, I don't know, pasta in it. And it had tomato sauce in it. And it had olives, garlic, onions. You might go, Italian food facies. Why? Because it's got those particular elements in it that enable you to recognise it. You go to another restaurant and you go, ginger, lemongrass, rice, you know, curry, Thai food facies, because of those components. And it's the difference between the components in the Thai food versus the Italian food that you make the connection from. You make it, even another one, you go to a hamburger joint and you get, you know, bread, buns, chopped up meat, slice of lettuce. That's American food. Sorry if there's a few Americans insulting. But the point is, there's 3 different types of food, and you recognise them by the clues that are in them as to what they are. Exactly the same story here. There are groups of rocks. You can call the Italian food facies. You can call that thing up there transgressive sand facies. Same deal. You know how to recognise the transgressive sand facies already. It won't be hard after you've worked on it to recognise estuarine facies, offshore marine facies, and maybe shore face type facies down here. Looking at this diagram again now it won't be too hard for you to figure out where those kind of facies are. There's your transgressive sand facies there. There's another one there. There's another one there. And there's another one there. Where's the estuarine facies? Okay, there's that one there. That's that one. There's another one there. That one. There's another one down there. There's another one down there. So the first thing to realise is that the rocks aren't a chaotic arrangement of random things. They actually are grouped and they repeat themselves. And there's only 4 or so main ones for you to recognise. So that's the idea of the types of rocks that are in the succession. Your job is to identify them, measure them, so that you go, okay, that's the top there, and that unit down there, and if I measure it off this particular log here, it's 1, 2, 2.8 metres of estuarine facies that sits up there in the top. So you measure where the top is, you measure where the base is. The top's at, in this log, 25 metres. The base is at 22.2. They're numbers that you need to have on your logs. And then in between that, there's a thing. And that's that stuff up there. And it needs a description of it. It's just like the Italian food facies. It enables you to distinguish what's the difference between that stuff up there and that stuff down there. We'll talk about how to do that a little bit more in a minute. The other thing that you need to do is you need to look at the boundaries in between, the contacts, okay? Because for every facies that you've got, there's got to be a spot where you stop and say that one ends and something else begins. There's different types of those contacts or surfaces. I made a really brief little list of them here. There's erosional surfaces, okay, where there are stuff going along and other stuff cuts it out and removes it. Looking along there towards where Lisa is, can anyone see an erosional surface? Keep your eye out. Look at this bit here. See this thing here? See how it cuts down there, comes up there? See, it's truncating stuff on the left-hand side. It goes up there, comes down there, and then up here it goes down again. It's eroding that stuff underneath, and that's an erosional contact. And it comes along here, it comes along here, and it cuts up through there. So that's an example of an erosional contact. This one down here, for example, or that one there, for example, that's a sharp contact. So this type here, I've shown it as if it was mud overlain by sand. So that's a sharp contact. And then I've made a gradational contact, which is one where one passes gradually into the other. They're important because when this happens, the gradational contact, that means that the thing that's underneath and the thing that's on top was once on the surface of the earth next to each other. And so one just became the other by the shoreline moving gradually out, or the river gradually building sediments over the top. It's a gradational thing. And so from that, you can identify that that was next to that when you're trying to make a paleogeography map. These other ones, the erosional contact, means they weren't adjacent to each other. That means something came and eroded out something else. And so chances are that might be an unconformity or something that wasn't next to the other thing. Got to be careful of those. The sharp ones can be both, but in most cases today you're going to find they're erosional or they're things that weren't next to each other. So between each facies that you measure in the column has to be a surface, and it has to be one of those kinds of surfaces. And you can see also that when we look a little bit today, you'll also find that there are burrowed surfaces. And they can be quite important because you'll see that they'll be juxtaposing one type of sediment over another with a lot of burrowing across the boundary. Now, look at this stuff in here. Bill's pointing to it too. See all that vertical burrowing through there? It's very characteristic. That's coming from that surface there. So that material there is separated from this material there across a burrowed surface. It starts there and drills down into the underlying material. This one is also a burrowed surface. See all the burrows coming down? So that boundary there is also a burrowed surface. In a lot of cases, they're burrowed surfaces because they stood there for a while and animals colonized that surface and then they drilled down into the underlying material for food or a place to live. Okay, and so they give you the idea that there is some time gap across that surface for the animals to colonise it and live on. Just to show you exactly how you might do that a bit more. This diagram is also from the place that we're looking at today. It shows what a vertical section or a core might look like with all these different kinds of biotubation or burrowed structures in them. And what it tries to show you is that there is a difference between this stuff down here and this stuff up there. Now they're going to be different fascies. And in this case, that fascies is actually that material up there. And this fascies here is probably that dark coloured material in there as a difference. Now, in order to tell the fascies, one of the critical features is to use this biotubation, because the biotubation over this whole area we're going to look at is pretty distinctive and it's rather important. Most of us don't know much about biotubation and different types. I'll try and point out a few that I know as we go through the day. But here's what you can do to identify what's going on in the biotubation. It's the same thing that Bill talked about before. There's diversity, okay? There's high diversity and low diversity. The Euryadesma was low diversity that we saw up there. So if you see something in here that's only got one or two types of burrows in it, that's low diversity. That would be this stuff. Okay, so there's a few Planolides and a couple of Tychicnus burrows. Down here, you can see that there's all kinds of burrows down here. So that's high diversity, that's low diversity. Lots of species, very few species. Second thing is abundance. We talked about that before. So is there a lot or is there not so much? And ichnologists, the people that study this, they generally classify it from 1 to 6. 1, none, 6, a lot. Everything in between, 2, 3, 4, 5. So that's abundance. And the last one's size. If it's a tough environment to live in, generally the critters are small. If it's a great environment to live in, they're generally big and robust and healthy. So that's what you can put on your diagram about the ichnology. Is there a lot of different types? Is there only a few or a real lot of them? And are they big or are they small? That's the basic way to do that kind of interpretation. That's probably enough talking. The idea is there's a slightly different scale, just so you get a little bit more detail in. The whole thing is about 22 metres or so, from where we start out here to when we finish up way back at the end of the platform. I'm going to suggest that you do it at 50 centimetres to a centimetre, or 2 centimetres to a metre on the scale in your book. That way you'll cover about 2 pages of the book for the entire day. So 10 metres per page, 20 metres or so for almost the entire story. It says in there to do it at a slightly different scale, but I think you'll get more information if you do it that way. The practicality of it is, if you're doing it, what you basically got to do is get there with a partner, and one person takes the notes and the other person measures. And if you're bored with that, well, you swap around during the day. But the practicality of it is, and so we're obviously not going to get back up there again to look at that, so you have to estimate what that stuff is. But if you go back up to where we climbed down the gully, you'll be able to see the overlying stuff a bit. You'll be able to see that boundary there. That's all accessible to you up there in the gully. So what you're doing is measuring vertically where the top contact is, where the bottom contact is. So the guy who's measuring will go, okay, 0 to 1.75 meters. Top contact, bottom contact, and then you will look at it and you'll go, this stuff consists of blah, 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 blah. Fine grain, bioturbated sandstone with ripple marks, high abundance, low diversity burrows that fine upwards, blah, blah, blah. That's your description of that unit. When you finish it, you get to where you started the last bit, and you go 1.7 to 2.8. Contact here is sharp, contact there is erosional. In between the material is fine laminated mudstone. Low abundance, low diversity bioturbation, small silty ripples, etc. Does that all sound okay? Any ideas or questions about how to do it or what it is? 50 centimetres. I think I said 1 centimetre is 50 centimetres, 2 centimetres is a metre. Yep. So one page will be 10 metres. Good, you got stuff to add about that?
No, that's the only thing I was going to add was that layer on top of the really muddy material there. You can see there's a sandy layer. I'm not sure what you're calling that, but you can see its thickness varies a lot. If you watch it, if you look over on the cliff face over here, you see it's actually quite a prominent unit sticking out at the decline about halfway through that muddy section. That's probably a reasonable mark. In fact, you see it right round on the next headland as well.
No, it's this one. Yeah. It's got cross bedding in it, as you can see up here. It's got an erosional base that it cuts out there, and it's only that thick. And then it immediately goes into this stuff above, and it's got that stuff underneath. That facies, this facies, that facies. I'm only using the basic facies today. If we really wanted to be, sort of picky sedimentologists, we'd probably call this stuff down here a little bit different to that stuff there. We'd probably call this stuff a little bit different to that. We'd probably call that different to that, and so on. But we're trying to keep it relatively simple. This one's a little bit of a different unit, but have a look at it and see if you can interpret a little bit. We'll talk about it later.
One of the reasons I pointed it out is because one of the difficulties you have when you're doing this sort of exercise is you do get lateral variation. So it's handy to have a marking unit that's laterally more extensive, so you can figure out where you are in the stratigraphy.
I won't bore you too much, but I think I wrote a few things down. I remember when I was doing this, when I didn't know much about it, and I thought, how the hell do you do this? There's actually some pretty simple things to do with it. Okay, what would differentiate the different facies? Grain size is a very obvious one. Okay, coarse grain, really coarse grain that we saw up there, those transgressive ones are really coarse. This stuff here is interbedded, silty, muddy. This is obviously really muddy, silty, muddy, sandy. So grain size is an initial way to differentiate them. Drop stones. Can you get drop stones in estuarine environments, do you think? No. You need icebergs to do it. So if you see drop stones isolated, particularly in sandy or muddy units, that's a marine unit because it can't get there any other way. If you see them all concentrated together, like we saw before, that means the marine unit's been eroded and they've got the lag deposit left behind. That's the transgressive sand shift. So the drop stones are important, but the context that they're in is important as well. Does anyone know what a hummocky cross stratification is? Should we know what hummocky cross stratification is?
We're going to see something.
All right.
They would have hurt the turn last year, but that was last year.
So there's a particular sedimentary structure which you don't see here, but we will see along the way. It's made of these broad hummocky features, fine-grained sediments that have got a very low angle, hummocky and swaley nature to them. They're diagnostic of the shore face environment. So they're a diagnostic feature. Channels are diagnostic as well. That thing there is a channel base, okay, that we talked about before. That one that Bill pointed out up there is a channel base as well. So channel features are important too. Do we get channels out in the main ocean? No. They're not. Submarine channels out on submarine fans in deep water, yes. But in the general marine environment, there aren't any channels. The seabed's generally flat. So channels aren't out in the marine environment. They're in estuaries or rivers. That's probably enough. This type of structure here, these kind of placer beds and linsen beds and so on, are very characteristic of estuarine deposits. So there's a few hints to get you along the way as to how to differentiate them and maybe how to interpret them a little bit in terms of the different sedimentary environments. You've got your partners, you've got your